All right, Chem 11, problem solving session. This is the title of the worksheet that I'm going to be doing tonight. I don't have a paper copy because everything's virtual now and I didn't print it off. Anyway, you have access to this sheet through your D2L site. I'm going to be going through it. Now, the first couple of sections of the sheet, the first section I think is on that handout. The first section was this stuff. It was particles, right, to moles to mass, right, which is in grams. This I'm not going to do on this work in this session, simply because we've done this. I think you guys have a good grasp of this. The second part, so part A was that. The middle section was percent composition. Again, I did a video on this. I think this is one of the easier things to calculate in chemistry, so we're good with that. I'm going to start with the third section, which was actually the empirical and molecular formula determination. So let's get started in that. Now, if you need help or a hand, because this is brand new stuff, you haven't done this before, if you need a help of any type with the first two sections, please reach out to me. Give a guy a yell and I'll help you out. Don't sit there and not know. You can't sit there and not know. This stuff is important for grade 12. So let's get started. What we will need is the Calculator-O-Matic 3000 solar powered edition. Awesome. So when the virus knocks out the power, who can still do their chemistry? This guy right here. So I've got that handy. The periodic table anemometer, 3000. Awesome, we'll need that. We'll need that for the average atomic masses that we're going to be using, because we use that as the molar mass to go between moles and mass, obviously. All right, so I'm going to have that to give me my molar masses. Now, what I'm going to do is I'll do the questions. The first question is, what's the difference between empirical and molecular formula, right? Well, we said empirical basically was the lowest terms, and I forgot the letter C. So this is the lowest terms, right, type of formula. And we said molecular was if you ran into this molecule out on the street, what it really looks like in all its glory, right? And so in our last session on YouTube, we looked at glucose, and its real formula is 6 carbons, 12 hydrogens, and 6 oxygens. And we looked at lactic acid. And the reason I did that is because they both have the same empirical formula. Right? So there's this 1 to 2 to 1, in this case 1 6, 2 6s, and 1 6. And here we've got 1 3, 6s, 2 3s, and then another 3. So it's got a 1 to 2 to 1 ratio. Obviously we don't show the ones. So that's basically the answer to number 1. All right, I know you guys knew that. That was obvious from the last video, but we got to start at number 1 before we can do number 2. Anyway, erasing that. Now, number 2 was one of our first problem solving things. So what I'm going to do is, there's 2 things we have to find. We might have to find the empirical formula, all right? If we have to find that, there's a series of steps. Now, those steps were on that sheet. I'm going to put them here in point form, hopefully small enough to give me enough space to work, but the first thing we had to have was grams. The question either gave us grams, or we could turn percent composition directly into grams. So we assumed 100 grams, so every percent would be a gram, right? Because 100%, 100 grams. The next thing we had to do, all formulas are based on amounts. Amount in chemistry is moles. All right? So I've got to turn my masses into moles. We've done that before. This is where our periodic table comes into play, right? To go from grams to moles, I need the molar mass. And then what we did is we divide by lowest moles. This would set up our formula and get rid of all those decimals and all of that for the most part. All right, so that's empirical. And then, of course, for molecular, if you remember, it was simply taking the molar mass and dividing it by the empirical formula mass. And that would give us a number that we'd multiply the empirical formula by. So basically, to do this, I need the empirical formula mass, which means I need the empirical formula, right? To get the mass of that using the elements on the periodic table, their masses. And then the molar mass will always be given in the question. If you're in a lab, the amazing mass spectrometer will give us that. All right? I'll see if I can leave these up here to kind of follow through the steps. I might not, depending on how small or neat I can write. Sometimes it's awesome, sometimes it's less than awesome. So let's do number 2. Try to keep this here. Number 2 was one of the ones that started off with a percent. So we have to change those into grams. So we had chromium, right? Chromium, which is Cr, and we had chlorine, which was Cl, and chromium was 32.8%. But I'm going to assume 100 grams, so that gets me started with my mass in grams. So instead of percent, it's grams, right? Same with chlorine. Chlorine was 67.2. I have to excuse my penmanship. But 67.2, and that was a percent, so I changed the percent to the grams. I assume 100 grams and that. The next thing we're going to do is we're going to change, now that we've got the grams, that's this done, we're going to change them into moles. To do that, we have to divide by the molar mass. So I go to the periodic table, right? And the molar mass for chromium is a nice even 52 grams per mole. And for chlorine, it is 35.45 grams per mole. I divide those out using the Calculator-Matic 3000. This one is 0.63 moles. And this one is 1.90 moles. So far, nothing really new. We've changed grams into moles by using the molar masses off the periodic table plenty of times. So I've got, this is how many moles of chromium there are and how many moles of chlorine there are in this compound. So now what I'm going to do is my third step, right? Divide by the lowest mole number. All right, so I'll see if I can squeeze that in. Divide by 0.63 moles. And again, the lowest number of these two, this is what I'm comparing, this and this. This is my lowest one. So I divide all of them by that, not just the one. Obviously, what's going to happen here, and if we bring our canceling into play, right? I'll do that here. Grams divided by grams is no grams, so grams is out of it. And then moles divided by moles, they'll cancel. So I'm just going to be left with the number. And obviously this one is easy. That one's going to be 1, because any number divided by itself is 1. And this one works out to 3. Now, if you get 2.99 or 2.98 or 3.02, whatever it happens to be, we round these off because these are going to be the subscripts in the formula. So I'm using these two numbers as the subscripts. So therefore, that's what these 3 dots mean. The empirical formula is Cr, I don't show the 1 even though we know it's there, Cl3. All right? Final answer. All right? So not too bad. All right? I was actually encouraged. Several of you sent me answers already before before this goes up, and you some of you nailed it, which was great. So perfect. It makes me realize that the D2L PowerPoint lecture notes are actually somewhat clear. When you get a few people that understood it, that's a good thing because you've never done this before, right? So it's good. It also shows that you guys are a pretty bright bunch, which means we can do a lot of good stuff. All right, the next question. So if you are looking this over, pause the video now. I'm going to move on to number 3. You can pause the video and take a look at this. All right, number 3. All right, so number 3 had 3 elements: carbon, hydrogen, and oxygen. And this was another one where it gave percent composition. So I'm just going to simply turn my percents into moles. So carbon was 68.53, or sorry, 54. And instead of percent, it's grams. Hydrogen's percent composition was 8.63. And instead of percent, I'm writing grams. And oxygen was 22.83%, which of course I changed the percent into grams. If I add up these numbers, they will add up to 100, right? Because it was a percent, 100% percent composition. So I've got my grams. I did that simple conversion. Now the grams have to become moles and dividing by the molar mass for each element. I get that off of the periodic table. Carbon is 12.01 grams per mole. Hydrogen, 1.01 grams per mole. And oxygen, 16 grams per mole. You'll start to remember these numbers as we work with them more and more. It's crazy how much it gets ingrained into your head. So we'll divide those out using the calculator Matic 3000, and we get 5.71 moles for that, 8.54 moles for hydrogen, oxygen 1.43 moles, and of course grams divided by grams, they'll all cancel out, leaving with moles. So I have moles left over, and that's what I end up with. Now I've just done this, divide by the lowest mole number, 581. So this one's my lowest mole number, so they all get divided by 1.43 moles. Moles divided by moles is no more moles. And we do that for each one, the same number. Whatever the lowest is, it applies to them all. Again, excuse the penmanship. I know it's awful. And 8.5 divided it out is 6 and 4. So therefore, my empirical formula is C4H6O1. I'm not going to show that. There's my final $1 million answer. All right. So this is for 3A. I had to find the empirical. Now 3B, there's a B part to this. I had to find the molecular. Now to find the molecular, I need the molar mass. That was given in the question. It's 70.1 grams per mole. The empirical formula mass, I'm going to get off of this. All right. So get a picture of this now. This was 3A, or pause it now and take a look at your work, see if you're following along okay. I'm going to do 3B, but I got to erase this, so pause the video now. All right, 3B, now I'm going to put a little note here. My empirical, we said it was C4H6O. All right, that's a 4. Oh God, it just keeps getting worse. Anyway, you know what it is. We just wrote it down. So what we're going to do is we're going to take our molar mass and divide it by our empirical formula mass. So the molar mass, that's always given in the question, right? Sorry, I was looking ahead. Our molar mass for this one is 140. I'll draw that neater. We're learning here, so do it neat, McDonald. Keep it together, bud. So the molar mass, this was given in the question, 140 grams per mole. So now what I got to do is I have to add up the parts of this, right? So what I do off to the side is I take, well, there's 4 carbons, which is 4 times 12.01, and then there's 6 H's, 6 times 1.01, only 1 oxygen, so that's 16. I'd add all those together, right? I'd add them all together, and I end up with 70.1 grams per mole. So that's the molar mass of the empirical, this formula, the lowest terms one. So I put that here. And you can already see these grams per mole divided by grams per mole, they're going to cancel. And 140 divided by 70, you already know is going to be 2. Now what this number tells me is that the real thing, the molecular thing, right, when you ran into this thing at the mall, right, or the grocery store, wherever it happened to be, the Tim Hortons, it's twice this. So I simply go 2 times C4 H60, and my molecular is C8 H12O2. Let's double that. All right. So again, pause it if you need to. Get caught up or write it down or take a look at it to understand it. I'm going to move on to number 4. All right. All right. I'm going to pick a different color here. Mix it up. We're going to try a little red action here. So 4. 4 was a similar question. 4A is finding the empirical formula, and it gave us carbon and hydrogen. So we have a hydrocarbon fuel of some sort probably here. It gave us percent composition numbers. So again, if it gives us percent, we change it directly into grams. So 85.60 grams for that, and 1440. Percent becomes grams. We assume 100 grams. That's the first step. We got grams. Boom. Second step, grams to mole. We have to divide by the molar mass for each element off of the periodic table. Carbon is 12.01. Hydrogen is 1.01. These values are on the periodic table. They're the molar masses, and that's how we convert mass into moles. When we divide that, grams divided by grams will cancel. I'll be left with moles. And so when I do that, carbon is 7.13 moles, and this one, hydrogen, is 14.26 moles. So I've done this. Now I have to divide by the lowest mole number. 7 and 14, it's the 7. So that'll be 1. Moles divided by moles is no more moles. And 7.13 will divide by the lowest mole number for this one, 2. And that, you can already see it's going to be 2. And therefore, our empirical formula is C, it's a 1, H is a 2. These become your subscripts, like we said earlier. All right? I think I can get B done in this space here too, so I'll have it all together. I'll do B in a different color, so we don't blend the two answers together. B we'll do in green. So B, again, we just figured out the empirical formula. We want the molecular. This will always be given somewhere in the question, and we have to find this. But we can find that because we have this. All right? So molar mass divided by empirical formula mass. The molar mass given in the question was 70.10 grams per mole. And the empirical formula mass, I take this off to the side. Carbon is 12.01. Hydrogen, I got 2 of them, so it's 2 times 1.01. When I add that together, it's 14.03. So that goes here. I took my empirical formula and I do this. So that's grams per mole. Bring that over here. When I divide, these two will cancel. Grams per mole divided by grams per mole is no more grams per mole. I just get a number and it's 5. And again, if this was 4.97, if this was 5.02, I round that off. This is my multiplier of how much bigger the real thing is than this. So I take that 5, I multiply my empirical by it, and I end up with the final answer of C5. 1 times 5 is 5. And 2 times 5 is 10. So C5H10. That's the final answer for number 4. $1 million answer right there. All the units are shown all the way through. Proper formula here. Showed my formula. Showed the units canceling. Did things perfectly. Just like physics. If I didn't put moles in here, I'd lose marks. Right? And there's nothing worse in chemistry as a teacher, or you can ask Mr. O'Meara, physics, the same thing. When the students know the process and they give away marks because they're not showing the units like grams per mole or moles or atoms or molecules if we're doing the particles thing. Show that. Get used to doing it, right? I know you know what the numbers mean, but please get used to using those units. Don't throw away your marks, right? Keep them. You want them. You want, need them in a couple of years when you're applying for college or university. So keep those marks in your own back pocket. Don't give them to me by not showing units, please. All right, that's a common thing that happens. People just throw away little marks. Pause the video if you got to take a second look at that. I'm going to go on to number 5. So far, sir, is 2 for 2. I'm killing this stuff. And I hope you're realizing this isn't really all that hard. This is actually pretty easy. I hope it is. If not, I hope it's getting easier. All right, number 5 we're going to do in blue. Number 5. All right, number 5. This one's a little bit different. They don't start off with percent composition. This one, they start us off with a mass for each element right off the bat. So we're not doing this. We're going right from here, and then we turn it into moles. So we have Fe, S, and O. And the whole thing is to find the empirical. So we're looking for the empirical formula for that. All right? Now, they start us off directly with mass. I have to copy these down correctly. Sometimes people will miss a 0. They'll add an extra 0. Please be careful. These values set up the whole rest of the question, and that's where marks will be lost. So 0.0769 grams, and then 0.0115 grams. So again, like people will go, oh, there's 1010, and for some reason they'll mess up here. Be careful when you're doing this. Copy down the values off of your sheets properly. So this question started me with grams, grams, grams. That's great. I needed grams to start this, to find the empirical formula, which is what we got to do. Change my grams into moles, which means I divide by the molar masses off the periodic table. So I got my periodic table beside me here. Iron is 55.85. Remember, molar mass, this grams per mole, is the same as the average atomic mass on the periodic table. Sulfur, 32.07 grams per mole. And oxygen is 16. I've used oxygen enough now, that's just, it's known. Actually, all these are known to me because it's not my first rodeo in chemistry. Anyway, we go through now. Here's something here where we got to be careful. This is 0.00024 moles. All right. This one also ends up being 0.00024 moles. And then this one ends up being 0.00072 moles. All right. So I'm going to divide this by the lowest mole number. This is where sometimes what will happen is this will only have 2 zeros and the 2 here, and it's actually bigger than this. So count your zeros. They all have 3 zeros after the decimal. So it's like 24, 24, 72. So what I'm going to do is I'm going to divide by the lowest mole number. Now I know I've been writing divide out here. I'm going to do it this way because I'm going to run out of room. So 0.00024 moles. It's still divide. It's just a different way of showing it. 0.00024 moles, and then of course 0.00024 moles. These ones will be 1. That's pretty straightforward. A little bit easier than drawing a number 1 for me. And this one ends up being 3. All right. So therefore, our empirical formula is FeSO3, 113, 113. All right. Now, a little hint. This one's ionic. It's a metal and a polyatomic ion, so it's an ionic. Usually they don't change. Usually they stay the same. So if I did the molecular for this, it probably is iron 2 sulfite, just like this one is. Right? Looks like iron 2 sulfite. It probably is iron 2 sulfite. Anyway, number 5, all it asked me for was the empirical formula. We found it right here. It's done. All right. Let's do number 6. If you want to take a closer look at this, by all means, pause the video right now. I'm going to move on to number 6. All right. Number 6. We'll do it in pink. Number 6 also wants an empirical formula, and it does the same thing. It gives me the masses right off the bat. So I've got the mass. I'm not doing this for that one. I'm not doing it. So for number 6, there's 3 elements. 1.36 grams of carbon. Hydrogen is only 0.23 grams. And oxygen is 0.91 grams. All right. The next thing I'm going to do, so I already have mass, turn it into moles, divide by the molar mass. So I'm dividing by the, also writing on an angle, I'm catching myself. Dividing by the molar mass of each element. Carbon on the periodic table, hydrogen and oxygen, right? And so I do that. Grams divided by grams will cancel, so all these units will cancel. Show those units, don't throw away marks. And what I end up with is, for this one, 0.113 moles, 0.228 moles, and 0.057 moles. All right. So I did this. Perfect. Last step, divide by the lowest mole number. The lowest mole number, 1, 2, 5, but there's a 0 in here. So this is my lowest value. Be careful of that. Every so often I catch someone and they somehow miss the 0 and they'll divide by this. And I know right away they skip this. So here's our lowest one. So we're going to divide by this value. So I divide by my lowest mole number, which was this. All 3 of them get divided by that. Moles divided by moles. That all cancels. All my moles are gone now. I'll just end up with 3 numbers. This one is 2. This one is 4. That one is 1. So therefore, my empirical formula is C2. H4, oh, I don't show the 1, and there you go, and we're done. Anyway, I hope this made sense. I hope it really helped out with the, between the lecture and the problems that were, shown on that, on your D2L lecture notes, and this, hopefully it's smooth sailing now. What I'm going to do is I'm going to put up another sheet just like this. It's going to have some molar chemistry stuff and some percent composition, because I don't want us to forget that. But then it's going to have more of these types of problems. Now, if you're thinking, sir, I know how to do particles to mass to moles, to, if you're good with that, skip it. If you feel 100% accurate, like, man, I'm nailing this, skip that and go right to the formula determination part. All right, so I'm going to post that on the D2L site right now, and you can get to work on it if you want. If not, it's going to be for tomorrow anyway. So we'll do that. Anyway, hope I made it crystal clear. Hope you guys are doing well. And if there's any questions, comment in the YouTube comment section below this video or reach out to me through Edsby. Anyway, have a great night. Hope everything goes great. Hope my answer is the same as your answers, because my answers are right. All right? Good night, everybody.